good evening all. So now we are discussing the last unit of the geotechnical engineering, that is stability of the soil slopes. So it contains the syllabus according to University of Pune. The syllabus is that is stability of the slope, that is introduction of the soil stability of slopes, that is various terms related to stability of slopes, and the classification of the slopes, either that is natural slope and artificial slope, and then the modes of failure, then the stability analysis of the slope. So in that there are four methods. Here we are going to find out the factor of safety of the soil slopes. The first one, that is Taylor stability number. Second one, which is called as the Swedish slip circle method. Third is called as the friction circle method. Fourth is the Bishop's modified method, and this method is applicable for cohesive soil as well as cohesionless soil. And the next one, last point, that is landslides. Concept of the landslides, what are various causes of the landslides, and remedial measures to avoid the landslides. Okay, so total lectures is 6 hours according to University of Pune. Okay, so the introduction part. So what is meant by this stability of slope? So what is meant by the slope? As we know that in unit number 4, that is shear strength of the soil, we learn that there is every soil mass which is having a sloping surfaces. Okay, generally soil mass which is having a sloping surfaces, due to which what will happen, due to action of the gravity, material will fall from higher elevation to the lower elevation under the action of gravity. Okay, so to avoid this sliding, we have created the soil having sufficient strength to avoid this stability. This is called as the shear strength of the soil. Okay, so let us consider, suppose this is your A point, which is at higher elevation, and B point, which is at lower elevation. Okay, and this is your whole soil strata. Okay, due to action of gravity, what will happen, this soil sample will slide and will fall into downward direction from A point to the B point under the action of gravity. So here gravitational force play the important role. Okay, so this will cause the shear stresses into the soil sample, shear stresses into the soil mass. Okay, so to avoid these shear stresses, we have to create some other stresses, or we can call it, we have to resist this soil sample. There is called as a shear resistance. Due to what is meant by the shear, this two soil sample are sliding over each other. This one soil sample, another soil sample slide over each other and falling into downward direction. So we have to avoid this sliding. Okay, so one force which is in upward direction to downward direction from A point to B point. So we have to resist this force. Okay, so here we are creating some resistance from B point to A point. So this resistance is nothing but the shear resistance, and this shear resistance, that is the maximum value of a shear resistance, which is called as sliding. Okay, so in this chapter we have learned what is meant by slope. Okay, so for a design point of view, the slope will be stable. Slope is nothing but that is the angle made by slope with the horizontal. Okay, angle with the horizontal, it is inclination with the horizontal. Okay, suppose this is your ground level, suppose this is your slope, so this is called as angle of slope, and this is called as the angle of slope, which is made with the horizontal. This is a horizontal line. Okay, so for our design point of view, our main as civil or engineer point of view, our main target is to stable the slope. The entire this slope will be this stable, to avoid the falling. Okay, avoid the falling or avoid the sliding. Okay, so in last 2 to 3 years back, we had listened that is a marine landslide. Marine landslide. That is marine. This is a village which is situated in Pune district. Okay, so there was a huge amount of landslide. Landslide means what will happen on there. So the large amounts of soil masses will be fall. Okay, will be fall from higher level gradient to the lower level gradient, and all this human activity and all other things get disturbed over there. Okay, so to avoid this disturbance or avoid this stability of the slope, here we are going to learn what is the analysis of the slope. Okay, and what are there. So there are generally two kinds of slopes generally exist. First one, that is called the natural slope, second one is called the man-made slope. Natural slope means the slope which are created naturally, or slope which is formed due to geological features of the earth. That is, let us say example, that is a mountain, or say hill, or say valley. Okay, these are the natural slope. Okay, these are the natural slope. So these, suppose this is your which is called as a hills. This is called as hill. This is slope. This is slope. If you take the reverse way, this is a valley. So this is the groundwater level. This is a valley, or we can say river. This is also slope. These are the natural slope. These are formed by naturally. Okay, and the second one, that is a man-made slope. Man-made slope. These slopes which are created due to some construction activity, or slopes which are created by mass. Okay, by our engineers. That is called the man-made slopes. Okay, so examples that is earthen dam. Okay, the earthen dam. Okay, the dam which is constructed by using the locally available soil materials or earthen materials is called the earthen dam. So this is called as a slope. So these are the slopes. The inclined surface is called as a slope. Second one is called as a canal. Okay, this is called as a canal. This shape of the canal is a trapezoidum. Okay, so this is called as a slope. Okay, so or we can also take the suppose the cross section of the road. Suppose this is your road. Okay, and so this is your face of the, this is called as the face of the cut. There is a cutting portion. This is actually your road. Okay, this is your actually road. Or you can also take one example, that is open trenches. Okay, trenches. This is also a slope. This is also slope. Okay, this is open trenches. So this is not a famous example, but your famous example is earthen dam and canal. Okay, so types of slope are the natural one and man-made one. Okay, so this natural slope is further divided into two categories, which is called as infinite slope and finite slope. Infinite slope and finite slope. Okay, infinite and finite slope. So what is meant by the infinite slope? Okay, what is meant by the infinite slope? Okay, so the infinite slope means the slope which is having a limited which is having unlimited boundary, which is not bounded at top and the bottom. Okay, so let us say the example of the, suppose we can take the example of the hill. Okay, so it is they are unbounded, and they are continuous or extended over infinite length. Okay, they are extended over infinite length, so we cannot measure the length. Okay, because they are infinite length, so their length is not finite. Okay, and they are not bounded at top and bottom. Okay, so this is the type of infinite slope. That type of that is called as infinite slope. Okay, so what is the definition of infinite? As its term indicate, infinite means it is extended. It's extended. It is not infinite. It's extended over unlimited length. Okay, extended over unlimited length. That is called as infinite slope. Okay, that means the slope that extend over the long lengths. So its example is, that is face of the mountain. The second one, which is called as a finite slope. So the finite slope means the slope that are bounded at top and bottom. Okay, so let us say that take the example of the earthen dam. So earthen dam is an example of the finite slope, which is the man-made slope. Okay, so this is a slope which are bounded at top and as well as bottom. This is bounded at top and bottom. That's why it is called the finite slope. That's why it is called the finite slope. Okay, so the so this finite slope is nothing but that is that so these are the infinite slope and the finite slope. That is an infinite slope means the term infinite slope is to used to designate the constant slope of the infinite extent. And the example, that is long slope of the face of the mountain. The finite slope, that is the finite slope is in limited extent. And the slope of embankment, earthen dam, these are the example of the finite slope. Okay, so next one, what is meant by stability of the slopes? That is design and construction of the earthen dam. And the slope failure that can be catastrophic, involving the loss of considerable property and many lives. Okay, so next point is that is the causes of the failure of the slope. So the various causes which causing the failure of the slope, that is the gravitational force. First one, that is the gravitational force. Second, that is the force, gravitational force, or we can call it self-weight. We can call it self-weight. Second, that is forces due to seepage of the water. That is the force exerted by seeping of the water. Then next, that is the erosion of the surface of the slope due to flowing of the water. Then the sudden lowering of the water adjacent to the slope. Then the forces due to earthquake. Okay, so let us see one by one. So first one, that is the gravitational force, or we can call as that is failure due to self-weight. Okay, so this is the infinite slope. Okay, so this is a infinite slope. This is whole is called as slope. Okay, this is the whole is slope. This is called the thickness of the slope. Okay, so this is the lower portion of the slope, and this is called the upper portion of the slope. So lower portion is the firm strata, or this is a hard strata, and so this is the upper portion, that is a smooth strata, or that is we can also call it the ground level. Okay, so due to this self-weight, that is self-weight. So this self-weight will move in the direction of the gravity. Okay, due to this self-weight move in the direction of gravity will cause the failure of the soil sample, and these kinds of slope will be occur. Okay, this dotted line will show the failure of the slope. Okay, due to action of gravity. This is in the case of the infinite slope, and this is in case of the finite slope. So this is due to self-weight. What will happen? This soil sample will slide into their downward direction. This is what the failure surfaces. So next, second causes, that is failure of slope, that is a seepage, seepage of water. Okay, so this is seepage of water below the groundwater table. So this is the groundwater, this is the ground level, and below this, if there is certain groundwater table exists, so certain there is a groundwater table exists, due to which what will happen, this soil sample will slide down in the direction of gravity, in the downward direction, due to this groundwater table. So this is also called as seepage parallel to the slope. Okay, so next one, that is called as sudden drawdown condition, or we can also call it the lowering of the water table. Okay, so let us take, so initially the water table is at point A, and due to some seasonal changes, or humidity changes, or temperature changes, the water level will fall from A point to the B point. Due to this falling of the water level from A point to the B point, the slope will be slip. Okay, this is our failure surface. And next, due to the earthquakes, as we know that due to creation of the earthquake, there are two kinds of the acceleration will be created, two kinds of movement will be created. First one is called the horizontal movement, second one is called as a vertical movement, or we also call it the shaking, or the vibration will be created due to impact of the vibration, due to which what will happen, the soil sample which is in a compacted condition, due to this vibrations, all the soil sample get loosened into small particles and will get slide down into downward direction. Okay, these are the various causes due to which soil sample gets or slope gets fail. Okay, so next one we have the discussing, that is Is why to understand the slopes. So first of all, the failure, that is a natural slope, we can call it the landslides, and the man-made slopes have resulted in a much death and destruction. Okay, so due to the, if the proper design of the slope is not there, so it will cause this loss of human life as well as the loss of property life. If the slope is stable, if the slope is stable, means if there is no sliding, okay, if there is no sliding, means your factor of safety you are considering is okay, is less than or is equal to 1, so your slope will be stable, so there is no any chances of the landslide or destruction. Okay, so we see the various examples of the various landslides when we are moving over the ghat area. So there are various chances of the sliding of the rocks or sliding of the soil sample onto the road surface. Okay, because the slope is not stable over there. The second one, the civil engineers are expected to check the safety of the natural slope and the slope excavation. As I told you, the factor of safety against the slope is very important factor, because when the your slope is stable, your factor of safety means we have to check the safety of the slope against the sloping surfaces. If the safety is not checked, that is factor of safety is not checked, it will cause that is as that is property loss and human loss. Or okay, then the slope stability analysis consisting the determination of the comparing the shear stress developed along the potential rupture surface with the shear strength of the soil. Okay, so in the introduction part we had discussed about, as we don't know that, so soil sample which is having sloping surfaces, due to which what will happen, the soil will get slide into downward direction, will causes the shearing stresses, will causes the shearing stresses. So we have to avoid this shearing stress, or we have to avoid this sliding. We are creating some resistive stresses, or so soil is having its own strength, or this strength, or which is called as the resistance to the this shearing resistance against this shearing stress, which is called as shear strength, which is called as a shear strength. So there are two kinds of shearing strength. So first of all, due to this sliding, and second one, that is we are creating the resistance to the sliding. Okay, so this shearing strength that can be calculated, that can be calculated by the Mohr-Coulomb law that we had learned in unit number 4. So this factor of safety we are calculating against this shearing strength, that is S upon 2, that is shear stress that can be that is required to avoid the sliding, and tau means the shear strength that is developed due to which sliding is happen. Okay, yes means shear strength that can be avoided sliding, and tau means the shear strength due to which sliding is happen. And this factor of safety we have calculated in all this entire chapter. That is nothing but the stability analysis, that is nothing but the stability analysis. So in this whole chapter we had discussed about this factor of safety. So this S or this tau that can be calculated by the Mohr-Coulomb law. So we know the Mohr-Coulomb law, S equal to C plus sigma tan of phi. Okay, we know this law. This is called the Mohr-Coulomb law. So C is the cohesion, sigma is the normal stresses, phi is the internal stresses, and S is the shear stresses. So depending upon that, we have to check the stability of the slope according to the factor of safety. So there are various methods. First one, there are the analytical methods. This is we are learning in part A. And part B, that is the graphical method, that is the friction circle method, that is the Taylor stability number, that is number, that are the graphical method. So in this whole unit, which is concerned with the factor of safety, you know that this whole unit is concerned with the factor of safety. So we know what is meant by the factor of safety for that purpose. So next is, so that is the slope mechanism, triggering mechanisms, or what are the various causes of the failure of slopes. We had earlier learned that is the intense of the rainfall. If there is a heavy rainfall, if there is a heavy rainfall along the sloping area, so obviously the slope will slip along that area. Then the water level changes, means the sudden drawdown condition means when the water level at A condition, water level at B condition, due to this changing of water level, automatically soil will slip on that area. Then the seepage water flow, that we had already discussed, that is seepage water flow. Then the volcanic eruption and earthquake shaking means due to earthquake. And last one, that is the human activity. Due to some human activity, that is construction along this along the neighborhood of the sloping area will causes falling of the soil on that area, will causes slipping of the soil on that area. Next, we discuss the various terms related to the slopes. That is various terms. So this is called as so this is nothing but our slope. This is our nothing but the slope. This is whole is slope. Okay, this is our whole is slope. This is our failure surface. This is our failure surface. So soil will fail in that direction, and direction of gravity. This is called the crest of the slope. This is top point. This is called the toe of the slope. This is called the crest of slope, and downward is called the toe of the slope. And this is called the beta. Is beta, and beta is nothing but this. That is called a slope angle. That is called as a slope angle. Okay, beta is inclination of a slope with the horizontal. So let us consider. So let us consider. So suppose this is your slope, and this is called as a beta. So beta is inclination of the slope. So this is your slope, inclination of slope to the horizontal, okay. So let us discuss one by one. First, that is a slip or failure zone. It is a zone of soil in the critical state of a residual state and result in a movement of the upper soil mass. Okay, this is called a slip surface. This is a slip surface due to this due to which soil sample will slip in that direction. Okay. The next one, that is a slip plane or a failure plane or slip surface or failure surfaces. So it is a surface of sliding. It is called a surface of sliding. Then the sliding mass, it is a mass of soil within the slip plane. Okay, so this is a sliding mass. Means this is a whole mass. It is a whole mass which is called a sliding mass. Okay, within this is within the slip plane. Then the slope angle. This is the angle of inclination of a slope with the horizontal. Okay, angle of slope with the horizontal. This slope is referred in terms of ratio. That is example 2:1. That is 2 horizontal is to 1 vertical. Okay. Next point is, that is the modes of the failure. Next point, or the second point, is modes of the failure. So generally there are three kinds of failure generally occur in the finite slope. First is called as a slope failure, or which is also called as a phase failure. Second is called as a toe failure, and third one is called as a base failure. Okay, so these are the three kinds of the failure will occur in the finite slope. Okay, so by one diagram I will clear the concept of these three kinds of failure. Okay, so this is your this is your earthen dam. So suppose this is your earthen dam. Okay, so if I take the section along this earthen dam, okay, so this will be look like that. Okay, this will be looks like that. Okay, so this is the first failure. So this is a curve which show the first failure. This is a second failure. This curve will show the second failure. Then this is the third failure. Okay, this is the third failure. Okay, so one by one I will tell you what is meant by these three types of the failures. Okay, so first failure is nothing but that is called as a slope failure. That is called as a slope failure. Means, so these kinds of the slope failure or phase failure, so these will occur above the toe portion. So these kinds of failure will occur when soil of the upper part is weaker than the lower part. Okay, so this is called as a phase failure. So this it is passing from phase to phase. So suppose this is your one phase and this is your another phase. Okay, maybe this phase to phase, this phase to this phase, this is passing from phase to phase. Okay, that is called as a phase failure or slope failure. So these kinds of failure is occur when when so this when the upper part, means suppose this part is weaker as compared to lower strata. So means suppose this part is made up of loose soil, and this part is made up of the hard soil. Obviously this part will be slip, okay, or will fail more rapidly as compared to downward one. Okay, so this failure Okay, this failure which is shown by this dot these lines, that is called as a phase failure, or we can call as a slope failure. Okay, so in this failure plane intersect slope above the toe. Okay, so second one is called the toe failure. Okay, so once again if we consider, so the cross section, I have taken the cross section, or we can say it's the half part of this earthen dam. So this portion is called as the toe, as we had a little learned. This is called as the toe and this is called as the crest. Okay, so toe means when the failure will start will pass from the toe. Okay, means when the failure surface is passed from the toe point, and the failure surface is passed from the toe point, which is called as a toe failure, or we can also call it as when the soil of upper and lower part is homogeneous. Means when the soil in upper and lower part is homogeneous, which means that, okay, if you plot the all three failures, so first is phase, which is passing from phase to phase. Second is called as toe, which is passing through from toe. Third is base, which is passing from the base. Okay, means soil in this upper part, means this part and this part is homogeneous. Homogeneous means which is made up of the same kind of soil, which is made up of the same kind of the soil. These kinds of the failure will occur. These kinds of the failure will occur. Means suppose this is made up of two. Suppose this is made up of murum. This is made up of murum. This is black color soil. So there is no proper bonding between these both two layers. So this layer will get slide on downward direction, and will this failure plane is passing from this toe point. So from this toe point. Okay. So next one, that is a base failure. So this base failure will occur, means this failure plane is passing below the toe and through the base. So this is your baseline. Okay, if you plot this, this failure plane which is passing below the toe at the base. Okay, so this is your base. This is your base failure plane which is passing through base. And these kind of failure will occur when lower part is weaker than the upper part. Lower part is weaker than the upper part. So means this part is made up of soft soil, and this part is made up of hard soil. Okay, so this is a hard soil, so it cannot be slipped or it cannot be moved. It is stable on that original position, and it is made up of loose soil. Due to this loose soil, obviously this part will get slide down, or we can say, suppose, so these are the three failure. Okay, and these two parts are made up of hard strata, and these are made up of soft strata. Okay, so this soft strata will slide in the downward direction. Okay, so means this failure occur when the lower part is weaker than the upper part. Okay. Okay, thank you. So now in next lecture we had discussed about various that is factor of safety. What is the factor of safety? Then the there is factor of safety for the shear strength, for cohesion, for angle of internal friction. Then the actual there is analysis of the stability of the slope for various conditions, for cohesion soil and cohesionless soil. And next the graphical methods. Okay, so later we discuss one by one by upcoming lectures. Okay, thank you.